Good morning, students. Today we're going to start our proofs. So what I'm going to do is I'm just going to take you through 7 proofs here, and I'll point out things to be aware of all along the way. A lot of these justifications, remember these are now called reasons, but justifications, reasons, the same thing, will be used in your proofs. So pay attention and memorize these ones. You should be familiar with most of them actually already. Okay, there'll be a few new ones. All right. So the first thing in a proof is to write down the given. Notice right here, here are the givens. All of them right here. All I do is copy and paste right here in your justification given. That means these things are all true. Now, if they weren't already marked on the drawing like they are here, I would do it right now after I wrote that down. Okay. Um, so the next thing is, remember, I'm trying to prove an angle equaling another angle. In order to do that, I need to first prove these two triangles congruent. And so remember what last class we learned about 5 ways of proving triangles congruent. AAS, SAS, SSS, ASA, and HL theorem. So we're looking to make one of those things happen here. And then after we prove the two triangles congruent, we'll be able to say that this angle is congruent to this angle by what's called CPCTC. Which is corresponding parts of congruent triangles are congruent. Okay. So right now I have an A and an S. Well, remember I told you, like when we looked at our worksheet yesterday in the last video, whenever we have two triangles connected some way, you're looking for either vertical angle theorem or if they share a side, reflexive property. So notice here, we see vertical angle theorem. So I can go ahead and write in the vertical angle theorem that this angle equals this angle. Now, remember, when we're doing this, we're using 3 letters every time. This is not angle C. C has 1, 2, 3, 4 different possible angles there. So that's a common error. The weaker students will put commons, just angle C, and therefore they get no credit for it at all. 3 letters in all your proofs from here on out for any angle. Don't even try. Even though I could call that angle E, this angle D, go ahead and use 3 letters every time so it becomes consistent. Okay. So now notice I have ASA, ASA. So now I can say that these two triangles are congruent by ASA is my justification. Now, remember we talked about corresponding order last class. So we need to make sure we do it in corresponding order. So notice I went ahead and did ABC. So that's like no arcs, right angle, 1 arc. Okay, so I have to go no arcs, right angle, 1 arc, EDC, right here, corresponding order. You didn't have to choose ABC, you could have gone BAC, you could have gone BCA, but if I go BCA, then I have to go DCE. If I go BAC, I have to go DEC. I have to still keep it in corresponding order. The justification is still ASA. So now that I've proven the two triangles congruent, remember I said after you prove the two triangles congruent, that means the other corresponding parts are also congruent. Well, angle A here is one of those other corresponding parts that match up with E here. So now I can say angle A is going to angle E by CPCTC. So one thing to note, you can only use CPCTC after you prove triangles congruent. You can never use CPCTC unless you've proven triangles congruent, the entire triangle. Not an angle, an entire triangle congruent to another triangle. Okay, your proof, whatever you're trying to prove, is always your last step in your proof. And you must write it exactly in the same order they have it in right here. Okay, as I mentioned right here. So here's just a note that so you're always looking for vertical angle theorem. All right, so that's proof 1. Proof 2 now. Here's our givens. Again, we put those in here and write given. Okay. And we would mark them if they aren't already marked. Well, in this case, they're already marked for us. Okay. I look here again. I see, oh, I have vertical angle theorem. I see this got slid somehow. That's what happened. That's why I was having to move those. Okay. So I have vertical angle theorem. So now I have to name that. How do I name this angle? As long as I go correspondence, it. So I chose to go B, CA. Well, B corresponds with D, so it'd be DCE, angle DCE, okay? And that's vertical angle theorem. We're already familiar with that, so that's nothing new, okay? You're always looking for vertical angle theorem when you have two triangles that are touching like this in the middle. So now if I notice, I see SAS and SAS. So the two triangles, which is all I'm trying to prove now, the two triangles are congruent. Remember, I copied down exactly like that. So I just copy and paste it, put it right there by SAS, and I'm done. 3 steps. All right, next one. Again, we write down our givens first. Always, never changes. Oh, by the way, on the park, for some reason, sometimes they don't put all the givens in one statement like this. They might put this given as statement 1, and then this statement down here is given as statement 3, reason statement number 3, and the answer still is given. So when you go and look on the park, you need to look and say, okay, I got to find all the givens, and then make sure I'm pick given first. So they split these up. After I find that one, I can say, okay, I got to go find that one. Where's that down here? And choose given in the drop down menu. Then go back and do the rest. Okay. So that's just a side note. Oftentimes I've seen that in the park where they split up the givens. So you need to make sure you identify each of them first and choose given and then go and do the rest. Okay, so back to normally this is what you do. This I've always been taught it. We never split them up. We write all the givens first. Okay. So I have this piece and this piece. Again, they're already drawn for me. This piece and this piece. Well, again, I see vertical angle theorem. So again, I'm going to put that in there. So make sure I name it in corresponding order. I'm doing YAZ. So it's 1, 2, 0. So 1, 2, and 0. BAC right here, vertical angle theorem. So now I can see I have the two triangles congruent by ASA, ASA. So again, I make sure I put it in corresponding order. I did 1, 2, 0, 1, 2, 0. Okay, I use the exact same order for this one right here. And it's congruent by ASA. Well, again, once I've proven two triangles congruent, then any of the other corresponding sides that aren't already marked. So BC would be congruent, or B and C is congruent to YZ. I could have marked that. But they're only asking me for AZ. Notice AZ corresponds with AC right here. So that's what they're looking for. They were looking to finally see that this one, AZ right here, is congruent to AC right down here. Okay, that's what we just proved through CPCTC. Again, here I have it written out. Corresponding parts of congruent triangles are congruent. Okay, so I didn't write it down up here. I just wrote it out right here what it stands for. Okay, again, only used after you prove the two entire triangles. So I forgot the triangle symbol right there. So let me copy this one and put it in right here. You need to have that triangle symbol because otherwise it could be referring to an angle. I'm not saying two angles are congruent. Our triangle is congruent to an angle on two entire triangles. You cannot forget your angle measures or your triangles or your segment bars or your angle bars. You got to remember all these things. You've already learned that in the first test and quiz. Okay. All right. There's 3 done. Number 4 here. Given. Given. Again, if they weren't marked, I'd mark them. Okay. Let's go ahead and erase this so you can see it from scratch here. Okay, so there's the givens. There you see your parallel lines and congruent here. Remember, when I have parallel lines cut by a transversal, the first thing I'm always looking for is alternate interior angles. In proofs, when we're doing triangle proofs, AIA, alternate interior angles are equal, is the most famous one used when you have parallel lines and cut by a transversal. Always remember that. First thing I'm looking for, AIA. So therefore, I have that. So now I can say WXZ. See, here's my corresponding order I'm going to use, WXZ. That tells me to match that up with YZX, which is what I have here, AIA theorem. Okay, so now I have an S and A. Well, don't forget, when I have a shared side, I automatically should be thinking reflexive property of congruence. So now I go ahead, and here's where you have to pay attention to the order. I can't just say ZX is congruent to ZX, even though they're the same segment. I have to look at the corresponding here. So on this triangle, if I say XZ, that corresponds with ZX, and that's what I did. XZ, segment XZ is congruent to segment ZX, reflection property. And if you want, you can write in of congruence. They'll write that out on the park, but I'm not concerned if you say of congruence. Reflection property is fine for me, but just so you know, they'll say reflection property congruence on the park. Okay. Um, so if I said ZX on this triangle, then it would be XZ for that one. Okay, so this is where I'm looking to make sure I put things in corresponding order. This congruent statement up here, I don't just say ZX equals ZX, congruent to ZX. I have to put it in corresponding order. So now I can see I have the two triangles congruent by SAS, SAS. So now I go ahead and state that, which is what I was trying to prove. Triangles congruent, remember it's the exact same order as this, by SAS. And I made a note, pay attention to corresponding order here. All right, number 5. Given angle K is congruent to M, there's your A congruent to M. L is the midpoint of KM. Prove the two triangles congruent. Notice midpoint, that's a vocab word. Whenever you have a vocab word up here in your givens, you're going to use that vocab word in your statement somewhere. Okay, and the definition of that vocab word. Okay, you're going to be using that. So L is the midpoint. What does it mean to be a midpoint? It means it splits it in half. It's the middle point of KM. So M to L is equal to K to L. So that's what I have. ML, segment ML is congruent to KL by definition of midpoint. It'll always be definition of that vocab word every time. So whenever there's a vocab word in the given, you'll be using that justification of definition of that vocab word, identifying what it stands for. Okay. Next, again, we have two triangles that touch. So we have in the middle here. So we have vertical angle theorem. You're always looking for that. Okay, so I have to make that statement now. MLP 120 goes to 120 here. KLJ. Okay, got to have it in corresponding order. You could have gone 0 to 1, and then it'd be 0 to 1 here. Okay, that's fine too. Vertical angle theorem. And lastly, now we see we have ASA, ASA. So the two triangles are congruent. I copied out exact same thing down right down here, and it's by ASA. I don't get to switch the order. Number 6, angles B and D are right angles. So again, that's a vocab word you're going to be using. Okay. Perhaps I could have, if I want to get even more detailed, but I went ahead and gave it to because I already have the mark right there. Okay. You could have said angle B was congruent to angle D, and you say all right angles are congruent. Okay. I'm not picky on that. I let that go. Okay. But here's a key vocab word: bisects. Segment AE, this segment bisects this segment. Notice it only talks about it bisecting this segment. It doesn't say BD bisects AE, only that this one bisects this one, so it splits it in half. Bisects means cuts in half. You know that from angle bisector. When it cuts the angle bisector, you just constructed that on your test. Okay, so I'm going to be using that. Since that's going to split that in half, I'm going to be able to say this is congruent to this by, so I have BC. I'm looking at the congruent statement. BC is congruent to DC by definition of bisector. Definition of that vocab word. So now I can put the hash marks there. So now I have an A and an S, an A and an S, and again, vertical angle theorem. 3 letters. BCA, so right angle 1 and 0, right angle 1 and 0, DCE. Okay, I can get that right from here as well. Vertical angle theorem. So now I have ASA, ASA. The two triangles are congruent, which is what we're trying to prove. Exact order is that, and it's by ASA, and I'm done. And lastly, number 7, segment JM bisects. You see that same word again, vocab. So we're using that. And JM is perpendicular to KL. Notice they only put one right angle symbol here, so that's where we're going to have to go ahead and use definition of perpendicular. Okay. All right, so first thing obviously is the given. Write it down. Now, bisect, what's that mean? It splits in half. It says this JM bisects this angle, so it splits in half. So I can now say KJM, angle KJM, is congruent to angle LJM by definition of angle bisector, or you can just say definition of bisector. I can't remember which way they'll use it on the park. Okay, but of course they have to have the word bisector in there. Definition of and then bisector. If they add an angle, that's fine as well. Okay. Uh, then I should see that they share a side. Automatic reflects their property of congruence. So I look up here again. I could, on the last one, JM didn't work, but look up here. JM on the left is still JM on the right. So JM is congruent to JM. Segment JM congruent to segment JM reflects the property of congruence. Okay, so we always know we have that when we share a side. Okay, so now notice, okay, now I only had one right angle here. Well, I'm now going to say these two right angles are both right angles because the definition of perpendicular. Okay, perpendicular means it creates a right angle. That means on both sides. Okay, and then so now we have ASA. So the two triangles, again, I copied the exact statement down right here. The two triangles are congruent by ASA. And that goes ahead and ends our 7 examples of doing proofs. So all of these justifications over here, and maybe in a few more over time, will be used in all of yours and on the park. So you get these memorized. You see the same common things over and over. Vertical angle theorem. Proving your triangle is congruent by one of the 5 ways, using CPCTC afterwards. Vertical angle theorem again, one of the 5 ways. Vertical angle theorem, one of the 5 ways. CPCTC after proving the two triangles congruent. Over here we use your AIA when you have parallel lines cut transversal. The most popular one is AIA that you're going to be looking to use. You have reflexive property when they share a common side. Okay, definitions of whatever these vocab words are right here you would be using. Okay, these are all the common ones. Okay, and you might have maybe 2, 3 more tops that you'd be using in any of your proofs. Okay, so now you can go ahead and start writing proofs, and we'll also look back at 1 or 2 of the prior proofs that we've seen either on the topic B, edge elastic, or in that review packet I gave you when I went over that, and it should now make more sense to you as well. Now you've seen all these examples. Okay, now you can work in your worksheet.